Hi everyone. So now we are going to talk about magnetic properties. So we know that what we see, the material which we see around us, they are not magnetic, right? They don't have magnetic property all the time. But some of the materials have magnetic properties. So how do we distinguish between the magnetic materials and they are not the materials which are not magnetic or which do not show magnetic properties? So to understand the difference between them, the magnetic materials and non-magnetic materials, we have to understand, first we have to get the idea about some basic magnetic parameters. Alright, so let's talk about these parameters and then we will understand what are the different types of magnetic materials, which are like magnetic materials but shows different they show different types of magnetism. There are materials which are not magnetic. Okay, let's analyze all of them. Before that, let's talk about the parameters. First one, magnetizing field. So you can refer the textbook, page number 149. So it's a theory topic, more of a theory topic. Let's discuss together. So what is magnetizing field? The magnetic field which is used to magnetize a sample specimen is called magnetizing field. So if we have a material, if we have a particular material, we want to magnetize that material. What is a magnetizing? Which means giving the magnetic properties or infusing some magnetic properties on that. That is what is magnetizing. So the field which we use to magnetize a material, which is known as magnetizing material. And what about the symbol which we use H? We use H to represent it. Okay, ampere meter inverse. This is the unit of magnetizing field. Okay. Second one, magnetic permeability. Magnetic permeability. What is magnetic permeability? So it is the definition. I'll read first. Then we will discuss more about that. The measure of ability of a material to allow the passage of magnetic field lines through it or measure the capacity of the substance to take magnetization or the degree of penetration of magnetic field through that substance. So by using the magnetizing field, we magnetize a material. So now we check how much is the magnetization of that particular material. So for that, you read it again. So there are different various reasons or various methods to understand, to estimate the magnetizing property of a material. So for that we use magnetic permeability. Okay. So now talk about magnetic permeability. The letter which we use in magnetic permeability is mu. But we have to discuss a lot of things about this one. Where first we have to understand what is mu, then mu r and mu 0. So you must have seen all of them, and mu 0 is nothing but magnetic permeability of free space. It's a magnetic permeability of free space or vacuum. Okay, and what about mu? Mu is nothing but magnetic permeability of a medium. It's for a medium. And what is mu r? Which is nothing but relative magnetic permeability. Okay, that is what is these three terms. Okay. The relative permeability, mu r, is defined as the ratio between mu and mu 0. Okay, that is what is the first thing. That is mu and mu 0. So I can say that mu r is equal to mu divided by mu 0. This is very important. Okay, so why do we consider relative permeability? Because mu value will be always, when we consider mu value, the comparison between two mu values is little bit difficult, in the sense that is, for example, we want to find out the mu value of different medium. Then it will be the value will be into 10 to the power minus 7 range. So the thing is, if we consider the mu r value, then mu divided by mu 0, that will be around in that term, in around this, which is less than 10, greater than 0. So one thing it is very sure that mu divided by mu 0 will give us a very good idea about how much is the magnetization. Okay, so again right, what is the unit of mu r? Mu r is unitless. Mu r is unitless and dimensionless. Okay, mu r is nothing but unitless and dimensionless. Okay, and then for free space, mu r is equal to, for free space or vacuum, mu r is equal to mu divided by mu 0. Mu 0 itself is it's a value of mu at free space. So the permeability will be 1. Okay, that is for free space. Again, I can say that this mu r value, so it's in an isotropic medium. In an isotropic medium, this mu r is scalar. But for non-isotropic or anisotropic medium, mu r is tensor. Okay. So look at the page number 150. You can look at the page number 150. So where the differences between scalar, vector and tensors are given. So what is the difference between scalar and vector? I don't have to teach you that, right? So but what do you know about tensor? So one example of tensor is strain is an example of tensor. Another one which is current is an example of tensor. So electric current, which is an example of tensor, you know that at each point it has direction but it does not follow vector addition. So this is what is the difference between tensor and scalar and vector. Okay, and vector. So you can understand, you read page number 150 and you will get the differences between vector and scalar. It's very simple, it is given over there. Okay. And now we are going to discuss the next one, that is intensity of magnetization. We will discuss in the next video.